Now, in this video, we will learn how to do the application of load on a simply supported beam and how do the analysis and get the results of bending moment and shear force in a simply supported beam. First of all, we need to set our inputs like the unit sitting here from the tape. So I will choose the unit kilonewton meter and centigrade. So if you are new in SAP-2000 and you are a structure engineer or a BSc engineer, you must know the uses of SAP-2000 CSI software, especially SAP-2000. And so this is a very basic and a very important tool for the civil engineers to do the analysis and to do the design of a structure. So let me show you a sample uh, demonstration for a beam simply supported. I choose a file. Here I choose a file. So I will choose a grid. Actually, this grid is in X direction. In simply supported beam, I will put 2. In Y direction, I have only I choose 1. In Z direction, I choose only 1. So I use the spacing. If I have a 3 meter span simply supported beam, I will use 3 meters. Okay. So these are the X, Y, and I need to check my plans. So I will use XZ plan. Okay. So we have two grids here, A, B, and in one direction. Okay. These are the grid levels. So I will first choose a demonstration because I am not a. This is a very basic uh, video for the students who are doing their analysis of simply supported beam and to understand the SAP-2000 interface. Okay. So I will choose from here. Already we have the draw column frames. So draw frames table. So I will choose this quick frame. Okay. So I will choose any frame is okay with me. Now it's very basic. I will choose this one. Okay. So I close this one and I will lock my assign from here. You come with your pointer. Come with your pointer. So you choose this one and assign. Assign you need to joint. So first let me do the joint selection. Both joint I have selected. I will go assign and I will choose the restraints. Okay. So here is actually I am going to the he simply supported. So my one end will be hinge. So I will just go and this like apply hinge. I will again go and select this one. This support need to be changed. So I will go assign. I will use restraint as a roller support. Roller support. Okay. So I have come out with my roller support. Now there are things I need to apply on this one. So first let me go to define load pattern. So I will use one load here. This is a dead load. So I will choose SDL. I am applying some load on this beam. SDL. I will choose a self-multiplying factor 0 because it totally depends on me how much load I need to put here. So for the dead loads, you need to delete this pattern also because I am not going to do the structure of self load of this beam. Okay, I just my study purpose. I will select this beam and I will go assign frame load gravity direction. Okay, so here is that we have the loads, but this is load patterns. So gravity multiplier, so gravity multiplier here is 0. So let me go and assign frame loads. I will first apply the point load. Okay, so point load depend on your application and location. So movements you can apply, and in gravity direction, okay, replace existing load. There is no load existing. So from distance 1 to distance 2, so absolute distance, I will use the absolute distance. So these are my point loads. So I will relative distance, you can see. This is 0. This is I will put 3 meters, so I will use 1.5 meters. Okay, and here should be my load. Load will be, and I will apply 5 kilonewton because this is my unit here, and the location will be 1.5. will be in the middle. In the middle there we have applied this load in downward direction. Now I will apply the uniformly distributed load or distributed load. Assign, go to the frame, distributed load, and this distributed load will be, I will choose 2 kilonewton per meter square. Okay, so I will choose OK. So this is our loads are applied here. So let me go to the display and show assign loads, frame loads, and all loads you need to show. Here we have the 5 kilonewton point load and 2 kilonewton per meter we have the distributed load. Let me run the analysis. Okay, so model case I don't want to run. So all do not run. So load case do not run case. Load also do not run case. Let me run the analysis. So I will show as a simply supported beam. Okay, supported beam. So save it. If you save it, we can go and we will show the display. Display for stresses. Okay, so these are the joints. So let me choose the Excel for this window, and I will go show forces stresses, strain and cable. Okay, so SDL I will check moment 33 because this will be my moment. So here is the moment 33. You can go display and you can check your moments 33 here. So you can increase your skill show diagram here. You can show this is your moment 33 and this will be the kilonewton into meter. Okay, so you can select this also, this diagram. So double click here and you can choose your diagram here. So distance location, this is concentrated load location, this will be the shear force, and this is your bending moment, and this is your deflection diagram. So you can use by clicking where you want to check the quantity, where you want to check the demand of these moments, and you can use this one also. So you can go again in display, and your second aim is to shear 2 Shear 2 mean is that it will be in the second phase and it will be on the downward direction and upward direction in the same phase. Okay, so this is your maximum shear force and maximum shear force we need to consider while designing these forces for shear. Okay, we also consider